says about A is equals to value of R is 0 less than or equals to R less than or less than B. Okay, 0 less than or equals to R less than B, where Q is your quotient, Q is your remainder. Okay, and A and B are some A and B are some positive integers. Okay, are some positive integers. Okay. So let's see how to deal with this. See, look at this number. I'm having 900. 900. How to write this 900? It is simple. You need to divide this 900, okay, using the other number, 270. Means I have the other number over here, 270. Okay. So when I'm dividing this one here, what would be the resultant? What would be the resultant? Okay, now when I shift this here, I'll have how much? 2 into 9 sir, 27 into 3. When I'm doing 270 into 3, the resultant is 0, 21, 6, 800. N is your resultant, right? Now when I'm subtracting, what is left out? 90 is left out. Means I should write this is your Q value, this is your R value. So I'm just substituting over here, that is into your Q value plus your R value. Okay. Now look at the next number. This number is repeated here. You need to remove this number, 270. This is written as like how? How do you write this? Look at this number. You need to write this number over here. Okay. You need to do this into. If I'm doing this into 3, I'll have that 270. Okay. Into 3 is your 270. Means the remainder is 0. Okay. Means what happens here is when I'm dividing 270 using 90. 93s are you are having 270. Okay, so this is your resultant. Okay, so at last what you need to remove, you need to remove HCF. HCF is your highest common factor. Now if you are observing this set of numbers here, which number is repeating on the RHS? This number is repeating, isn't it? 90 is repeating, so HCF is your 90. Simple. Okay. So similarly, let us look at the next one also. Now, if you are looking at the next one over here, right? So look at these numbers. You need to take only the bigger number 3822 equivalent to. So you should be having 196, isn't it? So what happens is when I'm doing 196 into 109 equal to 0. Means I need to write here 195 plus 0 as your reminder. Okay. So if you're looking at these numbers here, which are what is the highest number? The highest number is your 196. I hope this is also clear. So let's look at the next sum over here. If you're looking at this number 2032, 2032 is divided using 1615, isn't it? So when I'm dividing this one jar, I'll get 651 only, right? I'm doing here into 1 plus. What is your remainder? When I'm subtracting this over here, I have left with only 381. So this is your 381. Okay. So you can do this one over here directly as well, right? So this is your and so forth. Okay. Now I need to take the next number, the repeating number over here, and I need to divide this using the remainder, isn't it? 381. So when I do 381 into your 4, what is your resultant? The resultant is 4 are 2, how much? 150, 24, right? So here into 4. So what would be the remainder? The remainder is, I need to subtract this number, right? And I am doing this number subtraction, the result is 127. So this is your remainder, okay? This number is repeating over here, but you are having the remainder, right? So the remainder should be always 0. So what I should do, I will be taking at 381. Now, see, I will be hitting this into 3 times, isn't it? That's 0. So at last the HCF itself is your 127. Okay, see the number which is repeating, even this also repeating. But this number is having this number into it, isn't it? So this is your resultant answer. Am I clear with this? So let's look at the next one. I can write here A is equivalent to B into plus your R. Okay, now where Q is some integer given over here already. Now what I do here is I'm applying the Euclid's division algorithm. Okay, Euclid's division algorithm. Okay, now comparing these elements with this one, right? So, and I'm comparing A equals to BQ plus R with your CQ plus 1. Also with your 6Q plus 3. 6Q plus 1, 6Q plus 3, 6Q plus 5. So if you are observing this one over here, I will be getting. So let us now apply division algorithm with A and B equivalent to that B equal to your 6 and the value of R is from 0 lies or greater than equivalent to R is less than 6. Okay, see, because here you are having number 5, so the next number should be 6. Okay, so what we are getting here, the possible reminders, of R are, I can write R value from R equals to 0, 1, 2, 3, 4 and also number 5. Okay, so now and also let A equal to your 6Q or 6Q plus 1 or 6Q plus 2. Okay, and so on and so forth. Okay, where Q is your quotient, where Q is your quotient. Okay, now as we are having here, as you all know that any positive or integer. Okay, now I'm supposing A equals to the required series, right? So here A should be what? Any positive or integer only, positive or integer only. Then therefore the resultant of our equation reduces to any odd number, any odd integer is of the form if you are looking in this series here. Okay, what would be the options you are getting? You are getting 6Q plus 1, you will be having 6Q plus 1, 6Q plus the next odd integer is 3 or 6Q plus 5. Is it clear? See, we are having here 6Q, 6Q plus 1, 6Q plus 2 and so on up to 6Q plus 5. But the required odd integers are only this one. Okay. So let's look at the next one. Even we should do this also the same thing. Using Euclid's division algorithm, I am taking A equals to BQ plus R, isn't it? Okay. What would be your A value? A equals square value. Okay. So A is your square value. So let me take it over here. Let A be the square of the square of an integer. The square of an integer. Okay. So by applying Euclid's division lamina algorithm, that is A equals to BQ plus R, isn't it? Then I am getting here the values of R lies between 0 less than or equal to R is less than or equal to 3. Okay. So the possible values of R, the possible reminders, R is nothing but your reminder of reminders are 0, 1 and 2. That is, I can write, therefore, here I can write that A is equal to your 3Q or 3Q plus 1 or 3Q plus 2. Any square number is of the form. So I can say that any square number, any square number is of the form, what is written as is 3Q, right here, 3Q, 3Q plus 1, 3Q plus 2, where Q is your coefficient. I hope am I clear to this? Okay. So let's look at the next one. So Euclid, using Euclid's division algorithm, again you need to show this. Okay, let's see how to do this one here. Okay, here you are having cube numbers. Okay, so here you are having cube numbers. So using Euclid's division algorithm, let A be your positive number. Okay, positive integer. Now, by using Euclid's division algorithm, I can say that A equals to BQ plus R. Here the value of R rises from 0 less than or equals to R is less than or equals to what number? 9. Means the options of R may be 0, 1, 2, 3, 4, 5, 6, 7 and 8 only. 8 only. Okay. So therefore, you should be looking at carefully the required values. Okay. So here, what happens if we substitute the required values here? Now let us look at this one. If I am doing here a cube, so let A equals to your BQ plus R, isn't it? Now I can write this one as A equals to B as your 9. So B as your 9 cube plus R, as you know that B is equals to 9. Looking at this one. Okay. So what I'll do is I'll simply cube H1 out. Okay, so whatever I'm cubing, that needs to be done over there, right? So let's see the required options what we are having here. Okay, now when I'm doing some cube, if I write this one as a cube, this itself is a cube. Okay, this itself is a cube means how can I write this one if this itself is a cube? So that 9 cube plus R is also a cube, isn't it? So what would be the resultant of this one? What should be the resultant of this one? I should be taking here the cube value. Let me solve this one here. If I solve this, then I have some different values of R, right? Instead of this, we can prove that if you look at over here, R value eventually, okay. See, if you are expanding this, you will be getting 9 into 9 square cube cube plus 3 into 9 into your 9 square r plus 3 into q into r plus r. Am I clear? R cube. Okay. See, what I have done here is I have simply done this cube. Okay. So this is your resultant, right? So let's look at this one now. If I'm supposing, look at the last value. So this itself is your q value. Okay. So I'm assuming this to be a q. Okay. So I'm assuming that to be true. Then what happens here? If r equal to what was 0. If r equals to 0, then by observing this value over here, I will be getting a cube is equivalent to your 9m. I have taken consider this as m plus 0. Okay. And if r equivalent to 1, then the resultant of this one is a cube equals to 9m plus 1 cube. Okay, that's what 1 only. If r equivalent to your 2, if r equals to 2, then you are having a cube is equals to 9m plus your 2 cube. Okay, that is your 8. So I can write this as a cube is equals to 9m plus 8. Similarly, if I am substituting if r is equal to your 3, then you will be having a cube plus 9m plus your 3 cube. Then the resultant here is a cube is equals to 9m plus 27 plus 27. Am I clear up to? So here in this situation, I can write this one. Okay, let me write this a little bit. So fourth, you should be remembering here only the cube values of that numbers itself. Okay. Similarly, in the next step, if r equivalent to your 4, the resultant of mine is a cube is equals to 9m plus your 64. Okay. Here also the resultant of 64 means I need to do here 4 cube. So I'll get a cube is equals to 9m plus 64. Here also I am taking m to be. The m value would lie between. That is, I need to assume it as 9m plus 1. Okay. Similarly, in the next one, if I am taking r equal to your 5, r equals to your 5, that is, your a cube is equivalent to 9m plus your 5 cube. That is, a cube is equals to 9m plus 125. Okay. So, what happens to the value of this one m? Then the value of m needs to be 9m plus 8. This is repeating itself, isn't it? See here, this number is repeating. See here, this number is repeating. So eventually this number is repeating. So I can say that you can write it as from above it is clear that a cube is either in the form a cube is either in the form of a cube is either in the form of 9m or 9m plus 1 or 9m plus 8, isn't it? Since it is repeated here. Clear? Answer is proved. So let's look at the next one. I think this is the last sum of the exercise. Show that only one and only one out of this number is divisible by 3. It is divisible by 3. Okay. So you are having 3 different cases here. We are having 3 different cases. Let me divide as case number 1. What does it say? Let n be a positive integer. Am I clear? Let n be your positive integer. Then how can I write the value of n then? N can be written as 3q plus r, where the value of r, if consider let b equals to 3 here. Okay, so the value of r ranges from, r has the options of 0, 1, only 2. Okay, now consider r equals to 0. If I'm taking r is equivalent to 0, let me write it over here. If I'm taking r, I guess this to be next case. Okay, 3q, which is divisible, isn't it? It is divisible directly. Okay, it is divisible directly. And similarly, let me take r equivalent to 0, it is divisible by 3. Similarly, if I am adding some extra number, that is, if I am adding 2 over on the LHS, if I am adding 2 on the RHS, you need to add it over there also, right? Whatever you are doing on the LHS, you need to do it on the RHS also. So, these are not divisible. These are not divisible by your 3. Okay. So, let us look at case number 2. That is, if r equivalent to your 1, if r equals to your 1, then n is equals to 3q plus 1. Similarly, n plus 2 is equals to 3q plus 1 plus 2. The resultant of this one is 3q plus 3. It is divisible, isn't it? See, this is not divisible by your 3, but this is divisible by 3. Similarly, you will be having the next situation also, that is your n plus 4. N plus 4, the resultant of this one is n plus 5, which is not divisible by your 3. Similarly, let me look at case number 3. If r is equals to your 2, then n is equals to 3q plus 2, which is not divisible again. But if I look at that, n plus 2 equals to 3q plus 4, eventually these two are not divisible by your 3, isn't it? But what happens if I add the next number, n plus 4, isn't it? So this gives me 3q plus 2 plus 4. So the overall resultant itself is a 6. 3q plus 6. Hence it is